Autoline This Week is underwritten in part by...
In this epic battle of fuel efficiency and endurance, we're here to see which hybrid has the best MPG.
That's the essence of a hybrid soul. But is there more to it?
The Hybrid Game MPG Challenge.
And now, here is your host, John McElroy.
Want to thank you all for joining us here on Autoline This Week. We're going to be talking about rare earth metals, critically important raw material for electric cars and hybrids especially. And there's some real issues involving that material. And to get to the bottom of this, I've got three experts with me today, including Dr. Ed Becker, retired from the General Motors Corporation, Kevin Moore with All Raw Materials Consulting, and Jack Lifton from Technology Metals Research. And I want to thank you all for having been here with me today. Jack, let me throw it out to you, just so the audience understands, what the heck is rare earth metals, and how'd they ever get that name?
It's an accident. Originally, these things were found in Sweden around 200 years ago. And they were not common, and they got the moniker, so to speak, of rare earths. Earth in that time, 200 years ago, meant an oxide, a natural. They didn't know that's what it was. But an earth, when we look at what they called earths 200 years ago, we recognize these were oxides. In other words, natural materials that were very old and completely chemically reacted. No metals involved at all. But the name stuck. Technically, a chemist would call these the lanthanides. Because the first metal in the sequence that we call rare earths is lanthanum. And beyond, there's another 15. Lanthanum is atomic number 57. And the last rare earth is atomic number 71. So I guess that's 15. It sounds like 14 to me, but maybe it's 15. One of them does not occur on the Earth naturally. The other one, because it's radioactive and has long ago disappeared. The other ones do. And in nature, we always find scandium and yttrium, the two metals, along with the rare earths. So they've come to be called rare earths too. Technically, they are not.
And Kevin, it sounds like we human beings have found out something to do with these things.
Well, it's fascinating. It's finally they decided to start developing it, and they found some applications, and they realized if they apply them right, you get an awful lot of energy out of these magnets that allow them to do things.
And is that the key? We use these materials to make magnets, or are they used for other things?
There's a whole plethora of things. In military applications, they're using them in air conditioners, they're using them in electric bicycles, they're using them in just simple claps when they were real cheap in your purses and things like that. So they're very powerful, though. And it really gives you a lot of power in a very small package, and that's the secret to rare earths. That's the value they provide.
And Dr. Ed Becker, I got to believe there's a lot of automotive applications.
Well, just to expand, though, on what Jack was saying, not only are they not earths, they're oxides, they're not particularly rare. In fact, the concentration of rare earths total in the Earth's crust is more than copper. But because of their unique chemical properties, they don't segregate out into high-quality ores like the other materials we're used to. So one of the things we have to look at in terms of economically viable rare earths are the very seldom occasions where you find a significant concentration in one place. There's rare earth probably under the studio. We could stick a shovel in and find a concentration.
Oh boy, we're going to make ourselves rich here. Well, we're going to be digging after the show.
That's the hard part. No, there are many applications for the rare earths, including lasers, optical displays. The red color, the red phosphor in color television is europium, which is one of the rare earths. In fact, that was one of the biggest markets in the 1960s and supported the entire United States rare earth industry at that time. But since then, it was discovered that you could make these very powerful magnets with very high magnetic energy density. And the result of that is you can make electric motors that have extremely high torque for their size. And that is the real key to the electric vehicle. industry.
Because you can make these motors so much smaller.
Make them very small, relatively light, so that you don't need a lot of structure to support them in the vehicle, which makes the vehicle lighter and gives you a great advantage in terms of efficiency and ultimately mileage. Of course, with the latest goals for vehicle mileages, we're going to have to look at a lot of technologies to get there, but supplementing the gasoline or diesel motor with an electric motor is one way to increase the efficiency of the overall package.
And of course, the reason we're doing the show is not just to talk about how these things can make electric cars so much more efficient, but Jack, there's a geopolitical concern here too, because China has cornered the market on this and in fact has put a quota on exporting these things, especially to Japan.
What we did was, due to the operations of free market capitalism, we gave the Chinese this business. Originally, they were not involved in this. When Molycorp of the United States was the first large rare earth mine developed in the world, and that was in the late 40s. Everything was wonderful until the 80s. There wasn't that, as Ed said, the demand was entirely for europium and something called mish metal, the mixed rare earth metals. Now, those of us of a certain age who can remember a Zippo lighter, okay, for those who can remember smoking, okay, all those lighters had the flint, and it was in fact mixed rare earth metals. That was their largest use, okay? And that product was developed around 120 years ago in Europe. They imported the materials from the United States, and they made the material, and that's how that got started. In the 80s, the Chinese discovered that as a byproduct of their iron mining in Inner Mongolia is part of China, they had enormous quantities of rare earths. Today, because they bought the market by lowering the cost, they put the world's largest rare earth producer of the time, Molycorp, out of business, and we today get, they say, 97% from China. Well, I don't know what's the difference between 97 and 100, but let's say we get 97%. Here's the number they don't talk about. We get 100% of the critical rare earths from China. That's the problem. When they play political games, so to speak, with Japan, that affects us dramatically. We're buying our rare earths contained in Japanese products, washing machines, cars, things like that. And so the Chinese basically control this material, and I don't know if it was a plan or not, but it certainly worked out. It was predictable because people say it was an unintended consequence. I think it was extremely foreseeable, and for many years I have said in Detroit, I don't understand why you guys think that they're always going to supply us with this. Well, that's what they thought. So when the Chinese actually said, you know what, we'll let you know if you're going to have any, that sent a shock through the automotive.
That's basically what happened. I mean, China just recognized that it had a significant value. They had the ability to extract it very cheaply. They had a customer in Japan. And so initially they incentivized, and all the cities, and they incentivized all the cities with money from the government to build the industry. They could do it very efficiently, maybe not environmentally correct by global standards, and then quickly the market had the material and they had the technology out of Japan to make the magnets, and so it started proliferating through a lot of different applications. It became very attractive to engineering, and then China realizes that they control the game, and so that creates a huge problem for all the engineering groups and people developing these products, because all of a sudden you're not assured of supply and or a cost. So that's the real question here. What are the OEMs, what are major consumers, the GEs, the General Motors, the Fords, all these people going to do to assure the supply? It's the best solution, but if you can't buy it and it's not available, maybe it's not the solution. So that's the dilemma.
The analogy I like to use is the best conductor of all of the metals is silver, but we make our wires out of copper for a reason, and that's because silver's expensive. There are other magnetic materials. They're not as good. They don't have as high a density, magnetic energy density, but we can make motors out of less powerful magnets, and we can make motors that are called induction motors without magnets at all. The problem is all of the alternatives are bigger, heavier, and less efficient. So in a sense, we could make the decision, if these materials are unavailable, to design around it, but we would give up the increment in efficiency. And as I mentioned before, we have this goal out ahead of us to get up to a very high miles per gallon in not too long. We don't want to give up anything, but the other thing is, if parts of the globe have access to these materials and we don't, that puts us in an extreme disadvantage.
Which creates an incredible market all of a sudden, and you know how competitive automotive manufacturers are. They hear that one manufacturer is heavily involved in buying that material. There's a perception they'll have a competitive advantage in a critical area of car production. So it's really creating a dilemma in the market that people are really challenging themselves. What can we either do to substitute, or how do we participate in this to assure we have supply?
You know, to me, the biggest fear in GM marketing, and I'm using GM as an example, is to open the paper and have a Chinese car company with a showroom on Maple Road saying, you could buy a General Motors car, or you can buy state-of-the-art technology from us. Exactly. Because you see, they no longer use the high efficiency, blah, blah, blah. Okay, now, that is the real fear. The fear is the market. It's not military, it's not anything like, it's not even price. It's availability, security of supply, which in America we have overlooked since we thought we had everything, and what we didn't have you could buy. And when somebody finally said to us, I don't care how much money you have, this is my mitt, I'm going home, game's over. The Chinese didn't, I don't think they did this on purpose, but once they did it, they realized the power of it, and it's a whole new world now. You know, we're talking about rare earths. The Chinese have done a good job cornering tungsten. Nobody's paying attention to that, okay? And other materials. And they're out in the world buying raw material mines and refineries all over the place to supply China. And people tell me, well, it doesn't matter if a Chinese company owns a tungsten mine in Namibia, because it's a market. So if I offer more, I say, what if the Chinese say, we're not going to do that. This is for China. If there's any surplus, we'll let you know, but we've thought, and I've heard this in China, we really don't want to make inventory, so we won't have any surplus. So you guys are out of luck.
Where do we stand right now? Because I know going back a couple of years ago, China for the first time imposed export quotas on rare earths. Japan felt this the brunt of this immediately. But where do we stand right now? Are the Japanese getting what they need, and how about in the U.S. or the rest of the world?
If you're asking me, that they are getting what they need. Here's the real problem, again, that people aren't paying any attention to. It's not about that. The Chinese have never even, the quota has not been taken for the last 5 years. They always supply less than the quota because nobody's buying it. All right. Here's the problem. What's moved to China is the manufacturing engineering. We don't need rare earth permanent magnet raw materials in the United States because we no longer make rare earth permanent magnets, nor do we have the capability. We have the capability, zero capacity. So they don't have to do anything. As long as as long as the supply chain is totally in China, right. No one here has the capital to go into that supply chain at places that we invented, that we started. And as time goes on, people get old, they forget things, they die, and technology goes away. People have the mistaken belief that I can take a book off a shelf in an engineering library and build myself a nuclear submarine. It doesn't work that way. I need a lot of engineering continuity.
It's worth pointing out, too, that the quotas you refer to are on the rare earth metals themselves, not the products that are made from rare earths. There is no quota, for example, on magnets. And they would happily produce magnets for all of the world's automakers at whatever price
they do happily produce those magnets.
But continue to control the market
exactly right.
and be a risk for OEMs or whoever's consuming these products. So the problem we have today is, as they've alluded, there's lots of the metal out there, but there's a cost to get it out of the ground. But that is a very short of where you need to be. You have to be able to create the entire supply chain, the separation, the creation of the alloy, the production of the magnet, which is another patented process that is about to expire, but then there's also a bunch of other patents attached to that, so there's nobody ready to jump into the game. So what you have is the Chinese producing it, the Japanese that are dependent on it are producing the magnets, but now the Chinese are taking over the magnet production. So the Japanese are very concerned because they want to continue to be the producers. And so they're going to be out looking to try to create the value chain, maybe in North America. We hope so, because we need that supply here. So who are the partnerships? Who's going to finance this? Who's going to have the technologies? There's a lot of questions here, but it's exciting, but it's the best solution. And if it already exists somewhere today, somehow or another, investment has to come in, and the players have to come in and make this happen.
It's the best solution, but I keep hearing of automakers and their suppliers designing new electric motors that don't use any. You touched on this.
And that's correct.
And it may not be the best right now,
Right.
but you know, I've seen this industry take stuff that's awfully crude and refine it year after year, decade after decade, until all of a sudden, you know, look at the internal combustion engine.
Yeah.
Here we are 120 or 30 years later, we're still using it. Boy, because they've made so many improvements to
Exactly.
it. But could that happen with these electric motors that don't use this material?
It could. There is a very active research thrust in the United States. In fact, a critical materials hub was just designated at Ames Lab in Iowa. Among the things they're looking at are other magnetic materials that have the potential to provide equal amounts of energy and use less critical materials. Now, this is all research at this point. And they're not the only ones doing it. Probably the most active rare earth research takes place in China. They graduate more PhDs in rare earth chemistry than probably the rest of the world combined for decades.
Times 10.
Yeah. But the problem with designing an alternative motor right now is, as I mentioned, it's bigger, heavier, and less efficient. And once you've built your vehicle around that, you've given up the real estate, you've put in the supports for that heavier motor. If the rare earth magnets become available, you can't just switch it in and take full advantage of it.
And
our vehicles are designed, as you know, once you put a platform in production, the economics demand that you sell that platform for a number of years. You can't just switch it back in.
That's right.
And you know how competitive this industry is, right? Mm-hmm. So if one company has a competitive advantage and they're selling an electric vehicle or whatever with these motors in it, and they have this perceived value to the customer, and there's such a large margin differential today and so difficult to sell them, you have a leg up very quickly. So the other ones will have to react. So it's an issue that you have to go down these multiple avenues of development to assure that you're covering all your bases, because you don't want somebody to get leapfrog you by a significant amount and take market share. It's all about market share, right? So.
You said that you hope, Kevin, that we bring some of this production to North America. There's talk of opening or reopening a mine in California, right?
Well, there's multiple other mines right now, junior mines, what they call it, are very infant stages. They have a lot of issues, but there's a lot of interest in those. And I've been working with some of them, and the discussion always goes to, if you dig this up, you have to be able to get it further down the value chain, and the rest of the value chain can come. If you just dig it out of the ground, it's going to go over to China and be controlled, as Jack just said, anyway. And so you've got to be developing. But there's interested parties beyond the Chinese technologies that say, yeah, Japanese, for example, or other magnet producers want to be in this game. The growth could be tremendous, not just in automobiles, but in air conditioners or electric vehicles or bicycles or whatever, plus a military application. So if the material was there, the growth would be substantial and very exciting.
But it's worth pointing out that the Molycorp mine was a producing mine before, and so they have brought that back up.
But it was environmental concerns, right? There was all nasty stuff coming out of it? No?
No, they put it out of business economically.
But
there were accidents, but Molycorp.
But let me put it this way: to reopen that mine, many environmental issues have to be addressed.
Yeah, but the mine is running at the moment.
Yes.
Yeah.
And there are other mines in Vietnam, in Malaysia, that are starting up. But to go from the point of an assay and saying there's rare earths here to a producing mine is, I think,
longer than coming out with a new car.
Longer than coming out with a new car. And once you determine that you have a concentration of rare earths in the ground, you have to consider the political environment. You need a lot of water. You need a lot of electricity, and you need transportation. And there are places that have very high rare earth concentrations that have none of those things. So if somebody...
Arctic Circle, for example.
Yep, Arctic Circle, and the seabed mining is very...
How do you get it out of there?
And I want to say that Toyota, in fact, didn't it buy a mine in Chile or Argentina?
Toyota is developing a mine in Vietnam with the Vietnamese government. Only, as you might guess, it's not running real smoothly. It's not about mining. It's about politics. What I was going to say was we have a very unusual situation out in the West. It's hard to say the West because I'm including Japan when I say the West, China and the rest of the world. And so North America has lots of rare earths in mines. We even have we have a large operating mine in Mountain Pass, California. Well, and that mine has a plant to go downstream in adding value. It has a separation plant. Okay, that's it. That's it for the supply chain in the United States. We have nothing else. Europe has the total supply chain and no mine. They have everything else they need to make washing machines or cars, no mine. So they're trying to develop a mine, and the problem is, although they have, I think, the world's most advanced rare earth separation plant in Europe and France, the original one, it's company dedicated. That belongs to the Solvay Corporation. They're not planning to do it for anybody who just comes over the horizon with a load of rare earths. So what's missing, America has some parts of the supply chain, Europe has some parts, nobody has the whole picture. The next thing that might happen in your great-grandchild's lifetime is that all of these nations, which are friendly, allies, might sit down and say, you know what, maybe we ought to move things around so we've got the total supply chain among us. Until that happens, the Chinese are holding almost all the cards. That's the problem. The cost of developing the supply chain is immense, and you can't make the money back from this industry. So what are we going to do? I don't know. Innovation may give us better techniques for supply chain components, but right now the Chinese really are in good shape.
But economically, it's got to become more viable, like anything. That's really the key. And it's possible, but you've got to get the right partners together, and you've got to have the right investors involved and put the chain together. But I'm a bigger believer than Jack. Jack's a little more skeptical, but he may be right. But it's so valuable. I like to I use a comparison, and I know it's not exactly the same, but PGMs are on our catalytic converters. That was a solution.
What are those?
Platinum group metals.
Yeah, right.
Platinum, palladium, and rhodium specifically.
And that
the noble metal.
Right, noble. They're so noble. Anyway, so the late 70s it comes on, and my experience in automotive was our company was saying, oh, we're going to get this resolved and we're going to get away from these in the 80s. Well, the 90s come around. We've got a solution figured out, and it works just as well, and it'll work better. Come 2000, well, we're almost there. Don't worry, and we're going to eliminate these things. Guess what? We're still using them today. I see nothing on the horizon to be a better solution. They come from mostly South Africa and Russia, a little bit here in North America, and they figured out a system and a bartering system and an inventorying system and a trading system that it manages at a very high cost. So is it exactly the same? No. Is it possible to work out the same? Yeah, it's quite
great
possible.
analogy. That's a great analogy, and I'll tell you why. I always thought it was crazy in the 1970s that our emissions technology could pretty much only be sourced out of the Soviet Union or then apartheid South Africa. And it was just like, there's got to be another way. But to your point, we made it work then, and we're still using the same thing.
Right. But it's worth pointing out that for a catalyst, what's important is the surface. And what we found is to lay these metals down thinner and thinner and thinner to where we're using a tiny percentage of them. In a magnet, it's the whole mass of the magnet. So we can't reduce our reliance on magnets and still have the efficiency. We still need the same amount of rare earth to make a magnet.
Let's dig more out of the ground.
There's another good analogy here. In the last 25, 30 years, the world has developed a recycling system. We really recover a huge amount of these noble metals because there aren't very many. We need to do that. We do it. It's an international business, recycling of. There is today almost zero recycling of rare earth metals because it's very expensive. But we keep shipping back to China the magnets that we just bought from them. And in a way, they dust them off, put a paint job on them, and send them back. And in meetings with automotive companies, I say, well, let's take a look at a starter motor. How many times have you bought this magnet? Once. I said, no, this is 6, 7, 8. What's the life of the car? So, we got to do something about that. Well, then let's put $50 or $100 million on the table and build a recycling plant. Oh no, No, that's a lot of money. We'll have to have a meeting about it. That's the last you usually hear about.
But I believe very much that industry, scrap industry, is very refined, and they get it. It's too bad right now. They're just too far buried into the product. And like Jack says, it just goes in the form and they get disassembled back there today. But at some point, the shredders or the dismantlers, they're going to figure out a way to do that.
Concentrate it.
Remember, most of the cars coming back, and they're all over the car. They're in the little motors in your window. They're in every little motor has got one in it, and there are all other kinds of applications. But there's no efficient way of getting it out today. But there's not that many cars yet that are that concentrated.
Put a market demand there and watch the junk guys, go after.
They're pretty good.
They're
financially incentivize them. It'll happen at some point. But it's not.
We're down to the last minute here.
You started this show with a statement that I want to challenge. You were saying, well, because of the growth of electric and hybrid cars, that's not the point. Every car made today with an internal combustion engine has about a pound of rare earth metals in it. There's 775 million cars on the road in the world, 275 million in North America. There's all kinds of rare earths used in the car. If there's never an electric car built, again, or hybrid, there'll still be a huge demand for rare earth metals. Yeah. This is the hidden demand.
Yeah. And with that, we're going to have to wrap it up. Great discussion here. But Dr. Ed Becker, Kevin Moore, Jack Lifton, thanks so much for coming in and sharing all your thoughts and your knowledge, your deep, deep, deep knowledge on this. I really appreciate it. I hope all of you did too. And please join us again here next week for Autoline This Week.
Autoline This Week is underwritten in part by
In this epic battle of fuel efficiency and endurance, we're here to see which hybrid has the best MPG.
That's the essence of a hybrid soul. But is there more to it?
The Hybrid Game MPG Challenge.